Hello, so this is a CSM video walkthrough of problem 1 in the higher order functions section of the week 12 worksheets. So this is about a function called make digit remover, which takes in a single digit I, and so returns another function that takes in another integer, and scanning from right to left removes all the digit from the integer up to including the first occurrence of I, starting from the ones place. So if I does not occur in the integer, the original number is returned. So this is a nested function, so it's going to be kind of specific to whatever you first pass in. So remove2 is now going to be assigned to whatever function that make digit remover returns. And so when we call remove2 on an actual number this time, we're going to remove all the occurrences, including the 2, because specifically we want to remove 2's with the remove2 function. So this is going to return 23, and remove2 here, because we're moving everything up to and including 2, it's just going to return a 0 because 2 is up to and including 2. So finally, if it's not in the occurrence, then we can just return the original number as stated in the spec. Okay, so let's get right into it. We know that this is a nested function, so we take in an I that is going to be the number that we want to remove. And so we know we're going to return another function, and that is going to be the nested function itself, which is remove. So the first time we called make digit remover, we get a function that will allow us to remove according to this I that was first passed in. Okay, so remove is now going to take another number. And in this case, it's remove2. So we can just kind of look at this doc test and try to visualize everything. So in this case, remove represents remove2, and it takes in another number. And so this is where things start to get a little tricky. This already gives us a hint as to what we want to assign the value to. So we kind of want, in our case, we want to keep track of things that is left, because we want to be able to return it at the end. So yeah, so we want to So we want to keep track of everything that's left as we're removing things. And so removed is going to indicate whatever we have left as we keep removing things if necessary. Okay. So removed can just start out as n. So in this example of a doc test, it is just going to be this number. And so it can start out as n, and we can incrementally kind of whittle down removed until we get what we want. So while removed is greater than 0, which means that there is still numbers remaining, we want to keep track of this last number, because once this last number is equal to I, which is the stuff we want to remove, we just want to return whatever is left. So that is going to be our removed, because our removed is keeping track of whatever is left. So in this case, notice that the way this question is structured, we want to remove something before checking. And it's a little confusing, but that is because we want to remove all digits from the integer up to and including the occurrence of I. So if we just if we have whittled it down to 2, 3, and 2, and we check after, so sorry, we check before, so we take 2 and we see, oh, that's 2, and in this case, and then we are just going to return all of removed, which is not what we want, because we just want 23. But however, if we're whittled down to 2, we take this out to store it to check later. Then we whittle down remove to yet another one. We check this after, we see it's 2. We say, oh, we've now removed everything up to and including 2. Then we can just return removed, which is now just 23, which is kind of what we want. So in this case, we want to check after, not before. Okay. And so this kind of small indication in the spec is a little hard to miss, but it's great to kind of take out an example from the doc test and try to walk through it step by step, removing every number to kind of see. So yeah, with this example, we were able to see, oh, if we check it before, if we just take the last digit, we check it, oh, it's 2, and we want to return this entire thing. It's not going to be it's not going to be correct. Okay, so we know that we want to keep track of this last digit. So it's going to be the last digit removed, which is just modulo 10. And so in this case, it'll be 8, right? So now we're going to whittle it down before. And now we know that we want to check whether this number that we just whittled off is going to be equal to I. And of course, if it is, then we just want to return the rest. So this 232, we take this out, we kind of compare. If it's equal to I, then we're going to return the removed number. Okay. And of course, there's other ways to do this. You can maybe return the removed floor division 10 instead if you don't want to check after. That is another option, but the way that this is structured, the way that this problem is structured, is kind of hinting as to we remove first and then we check. So in this case, we want to chop off that last number, remove it, and then check and then return it. So it all depends on the skeleton and what is given, actually. So obviously there are other ways to do this, but for now we're going to stick with the skeleton. And yeah, so this is probably the most elegant way of doing it instead of returning a removed modulo 10, which is another way to solve it. Okay, and obviously, like the spec says, if I does not occur in the integer, then the original number is returned, which is just n. So yeah, if I is not in the number at all, then we're just going to return the original number, which is just n. And yeah, so that is if there's no removed returned, which means that I is not in the removed itself, then we're just going to return n. So yeah, more specifically, we're checking every digit to see if it's equal to I. So if that's not the case, then we kind of exit and just return n instead. And that's also another important distinction to keep track of, returning the number if I is not in the integer itself. But yeah, the main takeaway from this problem is to be vigilant in the wording and to use the doc test to kind of guide you in your implementation. So let's do a final check with the doc test, 23. So we know that the solution to this is going to be 0. So 23 is n. And so while removed is also going to be 23. So while removed is greater than 0, we're going to first take the digit. So digit is now equal to 3 in this first iteration. We're going to remove it in this line, and we're going to see, well, is digit equal to I, which is 2? No, so we're going to go back because removed is still greater than 0. And so now we're going to take the next digit, which is going to be 2. And then we're going to chop off remove. So 2 floor division 10 is equal to 0. And now we check, is digit equal to I? Well, yes, 2 is equal to 2, so we're going to return removed, and that is 0. And real quickly, 99, removed is equal to 99. And so removed is greater than 0. We're going to take this last number, store in digit, chop it off, check, is digit equal to 2? No. Well, okay, we go into the next iteration, removed equal to 9, which is still greater than 0. We store it in another digit equal to 9, chop it off. And is digit equal to I? No. So now we exit out of this entire while loop clause. We never got to return removed, so it's not going to be a 0 because 2 is not in it. And we just return n, which originally was 99. So that is kind of the flow of this problem. This is the most simple and elegant way to do it. And yeah, just make sure to always pay attention to the skeleton and kind of decipher what it's trying to tell you. We can see that there's an if check after you remove the last digit, so that's another hint. And yeah, I hope this helped your implementation and this made sense. So thank you for watching.